We studied how to conduct hypothesis tests for one population parameter, and we are ready to do our Excel project for Unit 8 of our Statistics OER course. And for that, we want to download or just view the PDF instructions and download the Excel file that is provided for us. And I will work on this Excel file on my desktop app. So for question 1, it asks us to do the hypothesis test in Art of Stat. Let's read the problem. We have the National Institute of Standards and Technology that provides exact data on conductivity properties of materials, and following are the conductivity measurements of 11 randomly selected pieces of a particular type of glass. Is there convincing evidence that the average conductivity of this type of glass is greater than 1? Use a significance level of 0.05 and assume that the population is normal. So this is an example of us not knowing the standard deviation of the population. Therefore, we will do a hypothesis test for the mean in Art of Stat, and that will use a t-distribution. So if I go in the web apps and I do an inference for a mean, the instructions say from the enter data menu, select your own and enter the data separated by spaces given to you in cell E1 of your Excel file. So here I'm in cell E1 of my Excel file, and I'm just going to copy this data, and then I will go in Art of Stat and I will enter my own. The variable is conductivity. And let me fix that. All right. And here I'm going to just paste that data. After that, from the type of inference menu, I want to select a significance test. And what is the null value for the mean from the null hypothesis? So I do want to do a significance test. And if I read the description, my alternative hypothesis is that I want to know if the average conductivity is greater than 1. That will be my alternative hypothesis. So my null hypothesis that contains the equal sign is that the mean will be equal to 1. So the null value for the mean will be 1, and my alternative is greater than 1, so that is a greater than test. And from the description, it says to select the appropriate test, so I'm selecting the greater than. And actually, I will also want to show the degrees of freedom and then take a screenshot, because I see it here in my Excel file. So make sure that when you are in this app, I see that the degrees of freedom are not showing, but I see here a box that says to show it. And now it's showing the degrees of freedom. And they want us to take a screenshot of our screen. So I launched the app for the screenshot. Remember, when you take a screenshot, to include the title of the app that you're using, all the graphs, and anything below the graphs provided by Art of Stat in your output. Take this screenshot and then paste it here in cell D19 and resize to fit in the box. There we go. All right, so I resized it and it fits in the box, and this concludes question 1 for 2 points of the 10 points in our project. For question 2, we will duplicate, we will add functionality in Excel to perform the same test. So what we want is to duplicate the Art of Stat screen. We want to highlight the title and the data values and insert a box plot of the data values. You see here that actually I got a bar graph, a histogram, but I also got a box plot here in the bottom. So it wants us to create a box plot. And to create the box plot, you have to remember that we need to highlight the title and the data values. So I'm going to go here, I'm going to highlight conductivity of glass and the data values, and I'm going to insert recommended charts, all charts, and I will go to box and whisker plot right there, and I'm going to insert that. And this is going to go here. And I can resize to make it fit the area. Let's see what else they want us to do in this box plot. Add a meaningful title and a label for the y-axis. In Excel, the variable axis is vertical instead of horizontal. So here, when I'm here, I want to add an axis title only for the vertical. And I also see that I have here this weird 1, which is the horizontal axis label, and I want to get rid of that. So I'm going to right click on it and I'm going to delete it. There we go. So here is my box plot. I need a chart title. This is conductivity of glass. And the vertical axis is the conductivity value. And if you want to make it a little prettier so that it resembles a little bit the box plot here in Art of Stat, you could potentially select to have a different lower bound for your y-axis. Here it is 0.85, but I see here it is a little bit below 0.95, say 0.94, and that will extend a little bit your box plot. You can also change the inside color of this graph to have a different fill, so you can select here the fill and the border. So you can play with this and make it as pretty as you want. I will not spend the time in this video to do that. So now that I have the box plot created, I want to start adding the inputs that the user entered in Art of Stat. So we want to edit the cells A14 and A15 to provide the full null and alternative hypothesis. So here the null value says that the mean is equal to 1. That was our alternative hypothesis. The null hypothesis is that the mean is greater than 1. And if we go back into our Art of Stat, we can either look in the picture or not. You can see here the null hypothesis, and you can also see the alternative hypothesis listed here. So the mathematical expression says that the null is m equal to 1 and that the alternative hypothesis is m is greater than 1. So what we do need though is we need just the value of 1 here. So in this cell B14, I will need that value. So enter the null value in B14, the number only, and the expression for the alternative hypothesis in B15 as those are stated in ArtofStat. So looking again here at my picture, I'm just going to put the 1, the number 1 in B14, and then in B15, I'm just going to write whatever ArtofStat says under the alternative, which is greater than. So greater than. And then I'm going to enter the alpha here, which was a level of significance of 0.05 per the instructions of the project. So here I'm going to do 0.05. And the next steps are to fill out row 6 using the functions count, average, and standard deviation. Choose the correct one, population or sample, to calculate the sample size, the mean, and the standard deviation in Excel. And then fill the cells D6, E6, and F6. So the sample size is calculated by the count function. If you just count these values, we already know that it is 11, so that's a good thing. The mean is the average function, and again I'm going to highlight those values. And the sample standard deviation, notice here that they are telling us it is a sample to remind us. stdev.s for sample, and again highlight the values. Right, so we have our values. We want to move on to part 5. Fill out the cells in row 11 using Excel functions. In D11, copy the value from B14. So don't type it in, just grab it from where the user entered it in the input. The standard error is the standard deviation of the distribution of the sample mean, and you have to use the formula that we have learned. And we learned that when we are doing the distribution of the sample mean, the standard error is the standard deviation divided by the square root of n. When we don't know the standard deviation of the population, then we use a t-distribution with an estimation of the standard error. The standard deviation of the population is estimated by the standard deviation of the sample. So the standard error will equal the standard deviation of the sample that we calculated. So I'm going to click on F6 divided by the square root of the sample size, which I calculated in D6. And then after that, I need to find the test statistic. So to find the test statistics, we will use the formula we have learned to find a t-score. And if you remember, the t-score is like a z-score. It's the value of your estimated statistic minus the mean divided by the standard deviation of the population. Now, this particular distribution here assumes that in the middle is the mean and the mean is equal to 1. Well, these are t-scores, so in reality, the x-axis here has t-values for t-scores. But to find these t-scores, you have to do your own calculation of the variable minus the mean, which you assumed in your null hypothesis that it will be equal to 1, divided by the standard deviation of the distribution of the sample means, which is equal to the standard error. So let's try to do that using locations in Excel and not typing everything by hand. So here, for the test statistic, I'm going to say that it is equal to, and I'm going to open parentheses for the difference in the numerator. And it will be equal to the sample mean that I calculated minus the population mean, which is the null value that I assume is true given the distribution that I'm going to use to do my hypothesis test, divided by the standard deviation. And this is not the sample standard deviation, but it is the standard deviation of the distribution of the sample means, which is called the standard error. So my test statistic will come out to be 2.101, and I'm going to double check here that also the value that I'm calculating agrees with the value that Art-of-Stat calculated. The degrees of freedom are equal to n-1. I am not going to type things in. I'm just going to pick them up from where I calculated them. So locations, like the project is directing us to do, I calculated the sample size n in D6 minus 1. And now I am seeing that I have duplicated the table here in Art-of-Stat with better accuracy for my calculations. And then we need to fill out row 16. We want to copy the text from Art-of-Stats in cells D16, E16, and F16. In G16, copy F11, and in H16, use the t-distribution function. So first, let's fill out the others, and then we can see the t-distribution function. So the population parameter is mean, mu. You can find the symbols in Excel under the Insert tab all the way to the right. You can go to a symbol, and the symbol will have these Greek letters. So I'm going to do this mu here. Let me close. I inserted it twice. The null hypothesis is H0, and that was that mu is equal to 1. And the alternative hypothesis, I don't know why it became so big. Okay. And the alternative hypothesis, I'm actually just going to copy this since I already have the symbols here. I'm going to copy it here and fix it. The alternative hypothesis is HA, and it will be mu is greater than 1. And that's the population mean of conductivity for this particular glass material. And then my test statistic, I already calculated it in F11, so I'm just going to pick it up from there. And then I need to find the p-value. So to find the p-value, we will use the t-distribution function. And this test, you have to choose if it is a left tail, a two-tail, or a right tail. And when we have greater than, and we can see here the shading in the graph in Art-of-Stat, this is a right tail test because it's only shaded to the right. I'm only interested in values greater than 1. This is a right tail. So the alternative hypothesis indicates what kind of test you want. So for the p-value, I'm going to do equals t dot distribution. And I'm going to pick two-tail, right tail, or if I don't specify, it will be a left tail. So I want to do a right tail, and it's asking me what is your x, and my x is the test statistic. And then it says comma, and then it's asking me what are the degrees of freedom, and I have calculated the degrees of freedom up here in G11. And then I'm going to close that, and the p-value will be 0.030969001. And again, I'm double checking with what I did here in Art-of-Stat. I did find the p-value to be rounded to 0.0310. And that looks correct as well. So the next question is, what should I do? And when you have a p-value that is smaller than what you are allowed to have an error of, you are allowed to make an error 5% of the times, and this looks like your p-value is a 3% probability of actually coming from this particular distribution, then you can say that you have collected evidence, which is your sample, that indicate that it is unlikely that this particular sample actually comes from the theoretical distribution that has a mean equal to 1. So you are prepared to actually reject the null hypothesis and support the alternative hypothesis. So your decision is either to reject the null hypothesis or to fail to reject the null hypothesis. In this particular example, we were able to find a sample coming from this theoretical population that is very unlikely to occur, which means that the theory of our hypothesis is probably not valid, since we have evidence to indicate that we have a conductivity that is greater than 1. And then the conclusion will say that at the 5% level of significance, the sample data produced enough evidence to support the claim of the alternative hypothesis, that is that the conductivity of this glass material is greater than 1. So evidence that the average conductivity of this type of glass is greater than 1. Don't forget to say that you are talking about the average conductivity, because we are investigating the mean of the sample. So that will be your task here, and it will not be included in this video, but make sure you write a good conclusion that includes the significance level and the correct statement of the alternative hypothesis.